Well, I've had a request for problem 15 from homework 3.3, which is differentiation rules. And I feel kind of silly because I just made an entire video solving this problem, but it was incorrect, so I'm making it again. The reason why it was incorrect is because I forgot to write m squared at the beginning of this expression. And so it's going to be the same sort of concept this time, so it shouldn't be too difficult to get there if we know what we need to use as our tools. So here we have a definition of every variable or constant. C is a positive constant. M is the amount of medicine absorbed in the blood, so that is going to be a variable. And R is the patient's millimeters of mercury of pressure. So in other words, the arm cuff will tell you what's your blood pressure, and the amount of medicine is going to change your blood pressure. So this is some sort of blood pressure medication. And what they want us to find is the derivative of this function, R, with respect to m. So what this is saying is as we change the pressure, how does the amount of medicine change? The rate of change of pressure over the rate of change of medicine. And that's what we're looking for. And the function is R, or the blood pressure, in a patient's body is equal to the amount of medicine absorbed in the blood squared times a constant over 2 minus the amount of medicine in the blood over 3. And you'll notice here is that there's only two terms with variables in them. So m is a variable. This term has an m in it right here, and this term also has an m in it. C is a constant, so we can ignore that, and based on we have two expressions that are multiplied together. We call that a product, and so we're going to use the product rule to take care of differentiation. So dr dm is going to be equal to, this is the saying I like, first d second plus second d first. And what that means is that I'm going to find dr dm, I'm going to take the first expression all on its own, so m squared times d second, which is d dm, of this second expression here, c over 2 minus m over 3. So there's the first d second plus second to c over 2 minus m over 3, c over 2 minus m over 3, and then d first, that's the derivative with respect to m of m squared. And now we have our framework line laid out for the product rule, so we'll just take our derivatives now. So I could rewrite this as m squared parentheses d dm of c over 2 minus d dm of m over 3. And the reason why I can do that is a property of derivatives called linearity. So because derivatives are linear operators, that means that if I have an expression that is subtracted or added to each other, I can actually just take the derivative of each individual component, which is really nice, especially for polynomials. In this case, the derivative of a constant, that's c over 2, it's a constant. Derivative of a constant is 0. The derivative of m over 3 is 1/3. So we have 0 minus 1/3 times m squared. That's going to give me minus m squared thirds. And I still need to solve this part of the problem over here, which is plus c over 2 minus m over 3. And the derivative with respect to m of m squared, using the power rule, we bring down the 2, and we subtract 1 from the power. That leaves me with 2m, and now I can distribute. So distributing 2m into c over 2, that's 2mc over 2 minus 2m distributed into minus m over 3. That's going to be minus 2m squared over 3. And it looks like we have like terms here. We can combine the 2m squared over 3 and the m squared over 3. They're both negative, so what that leaves us with is negative 3m squared over 3, so that the 3's cancel to 1, plus 2mc over 2. So the derivative, oh, and the 2's are going to cancel to 1. And what we're left with is the derivative of r with respect to m is equal to negative m squared plus mc. And I think, nice, we got it right this time. So there's the derivative. It can be weird because we practice with the derivative of x or the derivative of y, and then when they start throwing random variables at us, it can be kind of confusing. What's important is to define your terms. If we didn't know c was a constant, this problem would be a lot different. If we didn't know m was a variable, this problem would be a lot different. So it's important to define your constants and your variables, and then segment up the derivative. Kind of like we did up here. I said, well, here's one expression with a variable in it. Here's another expression with a variable in it. They're multiplied together, so we use the product rule. And just keep practicing, and it'll come more naturally. I hope this helped, and I'll see you next time.